All right, we are going to work on Math 102, Section 7.2. You try example number 2, question number 1. And so we're asked to find the vertices and the foci of the ellipse with this given equation. We're also going to graph it when we're done. Okay, so because, again, I just want to remind you of the standard equation. Of an ellipse. And this is specifically centered at the origin. We'll get to ones that are not centered at the origin in an example or two. So this is specifically centered at 0, 0. You want to keep that in mind. So that equation is going to be x squared over a squared y squared over b squared equal to 1. And the most important thing, or one of the most important things we need to remember, is that a is bigger than b. So I'll kind of use their locations interchangeably depending on which number is larger. That's what we want to focus on here. So looking at our equation, we've got x squared over 121 and y squared over 9 equal to 1. Looking at this, we want to think of both in terms of a perfect square, right? So this becomes x squared over 11 squared, and this becomes y squared over 3 squared equal to 1. Okay? Again, now our focus wants to be, well, which one of those two numbers is larger? That's going to tell us which way we stretch our ellipse, whether it's horizontal or vertical. So looking at these two, do you see that this one is bigger? Right? That tells us that we have a horizontal stretch. Okay? So we're going to be, maybe not this dramatically, but we're going to be more elongated like that. Okay? So we need to figure out a couple of pieces. It didn't ask us flat out for the center because we're only working at ones centered at the origin, but it's not a bad habit to write some of those things out. So the center is going to be at 0, 0. To find the vertices, you could follow the formulas that are given in the notes and in the textbook. However, my approach is typically, let's just start graphing and see what we end up with. So, if I sketch out some axes here, okay, again, I want to label X, Y, and make sure there's arrows across all of them. We know we're centered at 0, 0, right? Make sure we can see all this. We know we're centered at 0, 0, and this tells us we're going to go 11 in each direction underneath, 11 in each direction underneath the x-axis. So I'm going to count 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I'm going to put a point there because this is one of our vertices. And I may not have left myself enough room here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll make 11, that piece that was an arrow a moment ago. That's our other vertex. Okay, so we also know, because of this equation, we're going to go up and down 3. So from here, we're going to go 1, 2, 3, put a point there, 1, 2, 3, and a point there. Now, our book didn't necessarily name these other 2 points, but we've seen in the notes, and you'll see in some other videos as you go forward, sometimes we call them covertices, or singular would be a covertex. Doesn't hurt to know what they are. It doesn't hurt to be able to label them. So from here, we can mostly actually draw a sketch, and we should be able to figure out what are the ordered pairs for the vertices. Before I officially sketch this in, though, I really should figure out what the foci are. And if you remember, the equation for these foci, you write this out, is c squared equals, and remember we're going to say a squared minus b squared, always larger minus smaller, and that's because the standard equation has an addition sign there. Okay, so if this is addition, the equation you use down here is subtraction. Remember, they're always backwards. So c squared is going to be, for us, 11 was larger and 3 was smaller, so that's the order that we subtracted. C squared is going to be 121 minus 9, which means C squared is 112. We take the square root of both sides and we end up with C is equal to 10.58. Or if you'd like, this doesn't hurt because it's more accurate, you can actually factor this. I know it's divisible by 4 because its last two digits are divisible by 4. So 112 is going to be 4 times, let's see, 112 divided by 4. We get 28, so 4 times 28. And I'm going to keep factoring 28 because I know that's 4 times 7. So what that means is we can rewrite this 112 as C equals, or square root 112, excuse me, as 4 square roots of 7. So both of these are valuable, I think. This one in writing, because it's more accurate, like I said. This one in graphing, because it allows us to be a little more approximated as we draw this out on our axes. So let me slide back up here to our graph. What this value of little c for the focus, or for the two foci, represents is that's how far from the center we go, and we're moving in the same direction as our larger value. That's that transverse axis, or we'll kind of get to that major axis, we'll get to that later, value. So 10.58 is actually really close to the two vertices we've got, right? -10 and 10. So we can actually connect this, making sure we go through the vertices. So this would be vertex 1, focus 1, center, focus 2, and vertex 2. So if I go up a tiny bit, I want to add to this list where my center was, well, what are the ordered pairs for our two vertices? We can see one right here is -11, 0, and the other over here is +11, 0. We also have the ordered pairs, the coordinates for our foci, and I'm going to use my square root value from the bottom of this, so I'm going to say -4 square root 7, 0, that's here, and +4 square root 7, 0, that's over here. Again, I didn't ask you for this, but it doesn't hurt. You can also label the co-vertices. That's going up and down, so that's the value 0, -3, and 0, 3. So this is really a lot of the given information, or the requested information. You really only needed to do these middle two, but all of this is useful, as well as the graph. And you have that graphing tool on Canvas that you can use right underneath this question to verify your results. All right, see you in just a moment for number 2.